So what I have got is 1 over d of x into y. So I have to integrate x with respect to y. So y as it is, the integration of x is x square by 2. Now the complete solution is nothing but complementary function plus particular integral. The complementary function which I have got is phi 1 y minus 3x plus phi 2 into y plus 2x, and the particular integral is y x square by 2. This is the solution of the given PDE. So let's solve the next problem. Dou cube z by dou x cube minus 3 into dou cube z by dou x square dou y plus 4 into dou cube z by dou y cube is equal to e power x plus 2y. So clearly we can say that the given PDE is of type 2. Exponential term is there. So let's solve this. Auxiliary equation will be m cube minus 3m square plus 4 is equal to 0. If I solve this, I will get roots as m is equal to minus 1, 2, 2. Since it is a cube, I will get 3 roots. So if I write the complementary function for this, I will get, since minus 1 is distinct root when I compare with 2, 2, and 2, 2 is repeated roots. So complementary function is equal to phi 1 y minus x plus phi 2 y plus 2x plus x into phi 3 y plus 2x. Okay, so now let us find out the particular integral, that is 1 over d cube minus 3d square into d dash plus 4d dash cube into e power x plus 2y. Here a is equal to 1, b is equal to 2, because in the general form it is e power ax plus by. So if I substitute the values, d is equal to 1 and d dash as 2. So 1 over 1 minus 3 into d square is 1 square, that is 1 into 2 plus 4 into 2 cube into e power x plus 2y. So if I solve this, I will get 1 over 27 e power x plus 2y. E power x plus 2y. So the complete solution will be complementary function plus particular integral, that is phi 1 y minus x plus phi 2 y plus 2x plus x into phi 3 of y plus 2x plus particular integral, that is 1 over 27 into e power x plus 2y. Okay. So the next problem is d square plus 2 dd dash plus d dash square into z is equal to sine of 2x plus 3y. So clearly the third problem is of type 3, that is sine of ax plus by form I have on the RHS side. So let's solve this. Auxiliary equation will be m square plus 2m plus 1 is equal to 0. So this is nothing but a plus b whole square form. So I can write m plus 1 whole square is equal to 0. So I will get m as minus 1 minus 1. So complementary function, the roots are repeated. So phi 1 y minus x plus x into phi 2 y minus x. This is my complementary function. So let's find out the particular integral. 1 over d square plus 2 dd dash plus d dash square into into sine of 2x plus 3y. So I have to replace d square with minus a square, that is nothing but minus 2 square, and dd dash as minus ab, that is 2 into 3, and d dash as minus 3 square. So that is nothing but d square is minus 4, d dash is minus 6, d dash is minus 9. Sorry, d dash square is minus 9. So let's substitute these values here. We will get 1 over minus 4 plus 2 into minus 6 minus 9 into sine of 2x plus 3y. So pi will be minus 1 over 25 into sine of 2x plus 3y. So again the complete solution will be complementary function plus particular integral. So this is the final solution of the given PDE. The next problem is a bit different. So let's solve that. 4d square minus 4dd dash plus d dash square is equal to into z is equal to e power x plus 2y. So the auxiliary equation is 4m square minus 4m plus 1 is equal to 0. I can write this as 4m square minus 2m minus 2m plus 1 is equal to 0. So if I factorize this, I will get 2m minus 1 into 2m minus 1 is equal to 0. So m will be half comma half. Again the roots are repeated. So CF will be 5y plus half x plus x into 5y plus half x. Okay. So particular integral is equal to 1 over 4d square minus 4dd dash plus d dash square into e power x plus 2y. Now if you substitute the value of a to d square, that is d square will be 1 and d dash will be 2. So if you substitute this value, you will get 1 over 0 into e power x plus 2y. If you get 0 in the denominator, what you supposed to do? You should differentiate this and you should multiply x to that. So I can write 1 over 4d square. Differentiation of 4d square is 8d minus, with respect to x I am differentiating. So d dash will be constant. Differentiation of 4d with respect to x, it is 4d dash. This is constant, so it will be 0 into e power x plus 2y. So again if you substitute the value 1 to d and 2 to d dash, you will get 0 here. Sorry, I have not multiplied x. Okay, 1 over 0 into e power x plus 2y. So now again you have to differentiate this and you should multiply x squared to the whole term. So what you will get? This will be equal to x square into 1 over, if you differentiate 8d minus 4d dash with respect to x, you will get 8 into e power x plus 2y. So particular integral will be x square by 8 into e power x plus 2y. So my final solution will be complementary function plus particular integral. So now let's use the note which I have told you in the beginning of complementary functions particular integral, and we will use that note and we will solve one problem based on that. So the question goes like this. Dou square z by dou x square plus dou square z by dou x dou y minus 6 dou square z by dou y square is equal to y into cos x. So my RHS is of the form function of both x and y. So I can solve this as, again the auxiliary equation will be m square plus m minus 6 is equal to 0. roots are minus 3 comma 2. That means I can write this differential equation as m plus 3 into m minus 2 is equal to 0. This implies m is equal to minus 3 and m is equal to 2, isn't it? So the complementary function will be phi 1 y minus 3x plus phi 2 y plus 2x. So let's find out the particular integral. 1 over d square plus dd dash minus 6d dash square into y into cos x. So I can write this as factorized form, that is d plus 3 into d minus 2 into y cos x. So now I have to find out the particular integral for this. So what I will do is, this is 2d dash. 1 means 2d dash. Okay. Here, I will rewrite this again. It is d plus 3d dash into d minus 2d dash. So if you multiply this, you will get the same equation into y cos x. So what I will do is, I will write 1 over d minus 2d dash as it is, and I will write this as d plus 3d dash into y cos x. So in the beginning I have told you that if 1 over d minus lambda d dash into f of x comma y is there, then I can find particular integral by integrating this, like f of x comma c minus lambda x into dx, where c is equal to y plus lambda x. So this term is in the form of 1 over d minus lambda d dash f of x comma y. So I can write this term is equal to this, isn't it? So let's write like that. What I will get? I will retain 1 over d minus 2d dash as it is. So into f of x comma y means y cos x. So in the place of y, I should write c minus lambda x. Lambda value is 3 here. Minus lambda value is 3. So I can write this as integral c plus 3x into cos x dx. Okay. So integrate this using integration by parts. You will get 1 over d minus 2d dash as it is. You will get c plus 3x into sin x plus 3 into cos x. If you integrate this using integration by parts method, you will get c plus 3x into sin x plus 3 into cos x. So let's substitute the value of c now. 1 over d minus 2d dash as it is. C value is now y minus 3x plus 3x as it is into sin x plus 3 into cos x. So if you simplify this, 3x get cancelled, y into sin x plus 3 cos x. 1 over d minus 2d dash y into sin x plus 3 cos x. So again, this is of the form d minus lambda d dash. D minus lambda d dash. So what I will do now is, again I will write this whole term as integral of f of x comma c minus lambda x into dx form. So let's write that integration of c minus, now my lambda value is 2, so c minus 2x into sin x plus 3 into cos x, this term is as it is, into dx. So let's integrate this. We will get c minus 2x as it is. Integration of sin x, it is minus cos x. So I'm just using integration by parts method. Plus 3 as it is. Integration of cos x is sin x. So what you will get now? C minus 2x is nothing but minus y, because initially we will take c is equal to y plus lambda x. So that means c minus lambda x is nothing but y. So y as it is into cos x with negative sign minus 2 sin x plus 3 sin x. So minus 2x plus 3 sin x is plus x. So minus y cos x plus sin x. This is my particular integral. So final solution will be z is equal to cf plus pi. So I repeat, you can use this form only when you have d minus lambda d dash form denominator, or else you cannot use this method. So the next method is Monge's method. Here you will integrate the PDE, which is of the form RR plus SS plus TT, which is equal to V. So this equation will be of first degree, where RST's coefficients will be the function of x, y, z, p and q. That means capital R, S, T and V will be the functions of x, y, z, p and q. So let's see what is p. P is nothing but dou z by dou x. Q is nothing but dou z by dou y. Okay, so R we can write it as, that is dou square z by dou x square. This is, I can rewritten as dou by dou x into dou z by dou x. So I know that dou z by dou x is nothing but p. So I can rewrite this as dou p by dou x. Similarly, for t, it is dou square z by dou y square. So dou by dou y into dou z by dou y. I know that dou z by dou y is q. So this will become dou q by dou y. So for s, I can write s is dou square z by dou y into dou x, or dou x into dou y. So what you will write? Dou by dou y into dou z by dou x. This is nothing but dou p by dou y. If you interchange dou y and dou x, what you will get? Dou square z by dou x into dou y, that is dou by dou x into dou z by dou y. So dou z by dou y is q. So you will get dou q by dou x. So this is the values of R, T, S and PQ. So now we know that P is a function of x as well as y. So using total derivative concept, I can write dP as dou p by dou x into dx plus dou p by dou y into dy. So I know what is dou p by dou x. Dou p by dou x is dou square z by dou x square. Dou square z by dou x square into dx plus dou p by dou y is dou square z by dou y dou x into dy. Okay. So now that is nothing but dp is equal to, this is r into dx plus this is s into dy. So if I write for r, r is equal to dp minus s into dy divided by dx. So I got R. Similarly, if I use dq, since q is a function of x and y, I can write dou q by dou x into dx plus dou q by dou y into dy. Similarly, dq will become dou square z by dou x dou y into dx plus dou square z by dou y square into dy. This is nothing but s, this is t. So dq is equal to s into dx plus t into dy. From this I can write t is equal to dq minus s dx divided by dy. Okay. So now substitute r and t value in your equation 1. R and t value. So what you will get? R into dp minus s into dy by dx plus s into s plus t into dq minus s dx by dy, which is equal to v. So now in order to cancel dx and dy, I will multiply dx and dy to the whole equation. So what I will get? R into dp minus s dy into dx dy. So dx gets cancelled into dy plus s into s dx dy plus t into dq minus s dx into dx minus v into dx dy is equal to 0. Okay. So now if you simplify this, you will get r dp dy minus v dx dy plus t dq dx into minus s, I will take common, t dx whole square plus r into dy whole square minus s into dx dy, which is equal to 0. So let's give equation numbers. This is equation 2, this is 3 and this is 4. So any relation between x, y, z, p and q, you may consider any relation between these terms which satisfies equation 4, then it is obvious that it will satisfy for this part of the equation as well as this part of the equation. That means you will get a simultaneous equations. So you can write it as r dp